Hello and welcome. I have almost caught up on that crazy Saturday from a couple of weeks ago with all of the cases. I've got one more case left from MEWC DACH, which is the finals case called Mountains Are Calling. This is not a live attempt as I usually try to do because I did a test solve of this one, but wasn't particularly successful and I don't think it was particularly illuminating. That was a few weeks back, so I remember the broad strokes. I'll still have to read the details, so hopefully it'll be not so different from watching a live solve, just maybe a little bit better. But let's see how it goes. All right. Congratulations on reaching the final. Well, I didn't, but never mind. Now it's about climbing the mountain and ultimately claiming the DACH Excel crown. Fine. About the case. In the case, the challenge is to plan and carry out mountain tours. The case is divided into two parts which are independent. Within each part, the levels build on one another. Part 1, planning mountain tours. B1 to 3, L1 to 3. Part 1, various mountain tours need to be planned. For each mountain, the name, elevation, and reference point are provided. Additionally, the different reference points and their absolute elevation difference relative to mean sea level are given. Elevation differences of the reference points are given in centimeters, while the mountain elevations are given in meters. Okay. Good lord. Okay. So I'm just going to immediately make that into meters. Hopefully I don't regret that later. So then, yeah, I remember being confused about this, and I think I'll just let the questions hopefully make it clearer for me. So I'm just going to name this table, I guess, M for mountain. Just call that ref, and I think I'll just call this ref LU. And let's dive on in to see what happens. In the worksheet, list of mountains, you'll find different mountains, including the reference points. What is the elevation of the mountain at the given reference point in meters? Example. Weisshorn has an elevation of this above sea level. We want to know to do this, we calculate the difference between this and MEWC. So, okay, there's MEWC, and LN02 is here. So there's a difference of 4 centimeters. Subtracting that one. Okay, so we're going to look up this in, wait, actually, I think, so if we're subtracting that, that means we're adding that. So I think I just want to add a column here that's versus sea level. And that will be this. No, wait. Oh god, okay. First let's just do versus n, and that's going to be this plus VLOOKUP, this in refLU20. What? Normal, yeah, that looks right. What? Okay, I'm super confused now. There it is, right there, perfect match. What am I doing wrong? Oh. Ugh. Space meter, delete. Okay, there we go. And then I guess just for fun, let's also add one that's versus C. And so if are we adding that? So then this minus that. So Weisshorn to, oh, I don't bloody know what's going on here. Just tied myself in knots more. Okay. Should have just done it straight. So anyway, in M mountain returning from M height, no, versus N, I think is what I want. And then, yeah, so then LN2 versus there. No, what the hell? really truly confused. So ln2 is 4 centimeters lower, so we lower it by 4 centimeters. Okay. So if I do versus C, no, this is not making sense. That above sea level. God, I don't know. Make this one versus n, and then let's look at this in ref LU to 0. That's the wrong way around, so then I think that must mean that we should be subtracting this one and adding that one, and then yes. God, what a mess. Okay. So confused. Unit confusion, bit of a theme of the DACH weekend for me. Is that some rounding nonsense? No, it's not some rounding nonsense. What the heck? Oh my God. I'm just going to check what is the answer supposed to be, because really level 1 should not be going wrong like this. 2.8. Seriously? Ugh. 1.8. That is versus Adria. Adria versus, what do we want to compare to? There. So, that minus that is 0.9. Yeah, I think my answer is right. What? Oh, sweet Jesus. Okay, I don't know, whatever. Off by a centimeter. This is not the solve that I was hoping for, frankly. Alright, let's just do it a different way. Let's do it the way they're kind of suggesting. So we'll do x lookup this in M mountain, returning from M height. And then we'll x lookup M mountain, sorry, we'll x lookup this in M mountain, returning from M ref. And then this is height versus ref height, new ref height. So this is going to be VLOOKUP this in ref LU to 0. And then this is going to be VLOOKUP this in ref LU to 0. And it's going to be that minus that plus that. Answer. And then check equals this equals this. True. Okay. So the long shot, does that change? No. All right, well, there it is, 2 different ways. I don't know what is going on here, but I'm going to move on. First climb. Your goal is to climb a mountain with a height of X meters. Normal mountain comes closest to your desired elevation. Target elevation is this. This is an elevation of this above sea level. Okay. So then I think I want x lookup 0 in M versus N minus this, an absolute value of that difference, returning from M mountain, exact match your next larger item. Okay. Okay, that went better. Alright, you want to climb a total of 3 mountains, aiming to get as close as possible to the given total elevation. What the total elevation is given, so make sure you convert to this reference point, yes. Best combination of 3 mountains to achieve this. Climb each mountain only once per game. Fine. Sort the mountains by their elevation and provide the concatenated first letters. For all the questions, the elevation was chosen, so there's a unique combination. Might be useful to do a round 5 or similar. Okay, so First thing first, have I imported my lambdas? No. Then let's do that now. How many mountains are there? There are 83. So I'm going to say per com, from 83 things, choose 3 things. I want permutation, no repeats, not cumulative. So see, combin 83, 3, just make sure I'm doing it right, 91,000. Yes, good. Okay. Then I want to say by row this, no, sorry, by row index m height versus n, but oops, by all this stuff, some total height, and then letters in what order again? Sort the mountains by their elevation, highest first, and provide a concatenated first letter of their names. Okay, so actually, this might be better as a by row. Yeah, let's just do this. By row that, lambda row, and let heights be this. Names can be same thing, but for mountain. I guess we can just go straight to left of that. Then I want to h stack sum of heights with concat sort by names by heights. And I need to check in a second if I'm sorting ascending or descending, but for now that looks okay. Is that much slower, or is that just me? I'm not sure. Okay, so again, same idea. When I look up 0 in this minus this lock, returning from here lock, exact match or next larger item. Oh boy, that's not so good. What? Oh, sorry. In absolute value of that. Very important. Okay, so you're doing it the wrong way around. Is the long and the short of it. Sort by this sort order minus 1. Okay. And yeah, we didn't round anywhere. I guess let's round this to 5 decimal places just in case. I don't know. It'd be weird if that made a difference, but okay. That first level still, I think, the hardest thing about this so far. But anyway, in the worksheet mountain map, mountain massif is shown. Each cell represents 100 by 100 meters. The value shown is the average elevation above mean sea level, was the average elevation of the target cell. Okay, so just going to call this MP for map, as I usually do. And I'm going to add to, sorry, no, I don't have add to ref anymore. I just have to ref of this on MP. That's it. Okay. Local peak. A local peak is a peak where there is no higher point in the surrounding area. In our example, this means that every neighboring cell has a lower value than the current cell. Determine which of the local peaks corresponds to the given starting cell. From the starting cell, move to the neighboring non-diagonal cell with the highest value. If 2 neighboring non-diagonal cells have the same highest value, follow this priority. Okay, so south, north, east, west. And we'll just get the corresponding directions to RC of this with the directions north, south, east, west. Okay, so then I want to say 2RC of this converted into an RC reference code, so that's row 13, column 40. Then I want to say plus all of these. Actually, wait, sorry. I think I want to bump that over and let's just H stack 0 with this. So then, sorry, I want to say 2RC plus all of this. So I guess let's let NXT be that. HGT can be 2ref of NXT on MP. Those are the heights. Some of them are indeed higher. Then we'll, I guess, XLOOKUP 10 to the 6 in HGT returning from NXT. Sorry, exact match in a smaller item. And then to address of that. Okay, and then we, oops, sorry, I've got to lock that. And sure enough, before terribly long, that gets us to AN15. And then we'll just do a check. This equals this. And that will mean that we've gone enough steps. And if we haven't, then we'll do more. Part of what made my original attempt so silly was that I tried to do this as a recursive thing, and there's really no need to. It's very neat if you do, but there's really no need to. All right, still going. Looks like it's starting to stabilize now. All true. Yes, all true. Good. And then these should be the answers. And they are. Hooray. Okay, level 6, climbing the local peak. You start at the given cell and want to climb to the local peak. To determine the location of the local peak, use the instructions from level 5. Fine. How many meters combined elevation and cell distance do you cover on the way there? Distance between two cells is always 100 meters. What is this? Maximum of elevation meters. Path to the local peak is the same as determined in level 5. Remember, you always have to go to the highest neighboring cell. You shouldn't look for another path, even if that would be possible. However, there's also a maximum number of elevation meters you can climb per cell. If the required elevation in a cell exceeds the maximum allowed, stop at that cell and give the total meters of elevation covered so far, followed by an F. Oh my god. Okay, time for a model. Example 6. And we'll XLOOKUP this in here, returning from here. Okay, so then we'll go here, and then we'll just take this formula here. Let's just hard code this, I guess. And the rest can all come along. Really probably just made that a lambda, but never mind. I didn't. Okay. Then so this is address. I think I just want unique addresses. So that'll simplify things, yes. Height. And that is 2ref of this stuff on MP. Then I guess delta is it's drop this one. No, sorry. Drop this -1 minus drop this one. No, other way around. Okay. Stop. Actually, let's just make this VStack 0 with this, because then it'll be the same size, and that's a lot easier to work with. So now where exactly the stop happens is a question, but we'll figure that out in a second. So this greater than this means we stop. Let's do minus for all that. So then dist vscan 0 100 plus this sum. Doesn't look anything remotely like that. What? Sorry, oh, sorry, wrong one. Come down here. Okay, 216. That is better. All right, so it's not 100 on the first one. Blah. Okay, so I guess we'll just v-stack this with minus 100. Yeah, kind of. I really wish there was also an example of the other one, but never mind. Okay, so first step is to BO2 reaching 112 meters. Yes. BO52, yes. Next is BQ52. Wait, what? Oh, that's not good. Not going the right way. Oh, sorry. The next step is BP50. Okay, the next step would be BQ. Yes, but you don't make it. Okay, got it. That's kind of annoying, but okay. Bleh. So I guess I want to index this if error x match 1 against this minus 1, and if that's not found, then rows of this. Okay, and then I want to say, and if some of this, then f. Except, I don't know, it might need to be formatted as a number otherwise, so let's just do it this way. If some of that, then... Oh, never mind. So let's let a be that. I'm going to say if some of that, then a and f, otherwise a. Okay, and then we'll grab all the levels. Zero. Ooh, 0f is a scary result. Not impossible, I suppose. 108. 108 here in CN37, and the place that you would, where are we? Here, behind my face. Yeah, so the place that you would go from there is 2542, which is 100 meters up, and you can't. So, okay, I guess that's the right answer. I don't know. I want to not totally rely on. So there's also maximum. Yes. Stop it. So I'll get the total. All right. I don't know. Let's go with it. Yes. Hooray. Okay. Climb the XL mountain. One final ascent stands between you and the title XL Master DACH. Now you want to climb the highest point of the mountain range. First determine its location. Note this is a bonus question. Okay. Always move diagonally toward the highest point. Okay. Okay. Alright, so this is kind of similar to level 6. I guess let's go and do the bonuses just to be tactical. How many mountains end with Spitze or Spitze? Okay. Count diffs. Diffs. The mountain is star Spitze. What is the total height of all mountains whose elevation is given in MEWC to provide the height? Monster, Benny. Pretty sure I got this one wrong when I did it before. So let's just look at one of them. Look at some of them. So these are the mountains given in Adria. But if I want to convert that to versus mer, then it should be 9 centimeters in the difference. The ln2 made it 4 centimeters to be 9 centimeters higher. I think. No, 9 centimeters lower. Oh god, I'm so confused. Okay, the example here, level 1 example. It reduced by 4 centimeters because this was 4 centimeters further down. So these should reduce by 9 centimeters. So let's see if that is in fact what happens. 42, no. What the hell? Oh no, sorry. Yeah, you're going the other way. So going from mer to ln2, you lost 4 centimeters. Going from Adria to mer, you should gain 9. Okay, fine. So I think that's right. So then, and round your answer to 2 decimal places. We're going to say round some ifs m versus sea level, where m ref is x, and then I'll just go copy it, round it to 2 decimal places, and this I'm not going to attempt to write by myself. Okay. Why is that not shown to do that? Okay. The total elevation difference across all mountains between the given reference point and the height above normal. Between the given reference point and the height. Okay. Then I want ref versus n. I think just means this. Or should it be the positive of that? I have truly no idea. Round to 2 decimal places. Okay, so we'll paste with sum. And then I think I have a wrap with round. Okay. Where's the highest point on the map? State the cell address, e.g. A1. Okay, so what do I do here? I guess I want to say at sort by addresses of, sorry, I guess it'll be to call of addresses of MP. And we want to sort it by to call of MP. So we're going to sort by minus that, and that'll start with the biggest one, and that's it. And we just go quickly check CD76 should be a large number, and it is. Where are we? CD7, there it is. It looks in the middle of the red, that seems fine. Okay. What is the height of the tallest cliff? A cliff is defined as the elevation difference between one cell and its neighboring cell. Consider only horizontal and vertical neighbors, not diagonal ones. Okay. So I think I want abs of this minus this. On the max of that, and also of abs, comma, abs of this minus this. I think that's the answer. Okay, so now level 7. Probably run out of time, but never mind. Okay, so I'm just going to rename this L6 because L7 should be pretty similar. Come on. L7. Let's just turn off data table calculation since that seemed to be going surprisingly slow. And we don't need it here yet anyway. Okay, so example 7, and if let's look up this in here, where are we going here? Returning from here. Okay, so now, yeah, so we're aiming for where? CD76. Okay, so equals to row equals to call. So then it's going to be RCR. It's going to be 2RC. Then it's going to be 2 row of that. It's going to be 22 versus that 76. So it should be this block minus that, and sine of that times m plus sine of this block minus 2 col of this. Oh, sorry, all of that plus this. So that shifts it one step, and let's just do 2 add so I can look at it. Sorry, point this one up here, and there won't be a circularity. Okay, so you go to W23, and on and on and on, and oh, you stop going. Oh, that's not good. CD76. Oh, yeah, you're trying to get to, that's not good. Oh, what? So you should be increasing the column number instead of decreasing it. Okay, sorry, what is this? So increasing the row number, which you should be, but for some reason you're decreasing the column number. What? Oh, it's the wrong two column. Yeah, I did know I was taking a bit of a risk when I gave my functions names that already exist, but never mind. Okay, so then, I don't know, let's say it's not going to take us more than 120 steps for now. And we'll point this to here, and then the rest should be the same, 1745. I'm just past the 30 minutes, so probably should not have gone to do bonuses, but never mind. Need to work on my tactics. Okay, and calculate that. And is it right? It is, hooray. So these weren't marked, so I don't know. Hang on, let me look at the answer sheet and see if I got those right. 25, 91, 295. Huh? Did this? It did say around. Oh yeah, no, there aren't. Okay, it does agree. They're just not shown for some reason, but fine. 21.54, CT76, and 388. Okay, cool. So yeah, I got everything except some of level 1. I'm hoping that's just a mistake. But anyway. All right, definitely smoother than my first run through. That is all I've got for today. Thanks for watching. See you next time.